Hi, I'm Peter,
And I'm Jed.
and this is Lab 1, the threshold lab for digital.
We will be looking at a 7404 inverter chip for this lab. So here is our data sheet. We use the top diagram to hook up our wires.
This is a diagram of our schematic. Not included is the 5 volts used to power the chip. Basically, if the switch is open, the 1 port gets a 0 and the 2 gives off a 1. If the switch is closed, the 1 gets a 1 and the 2 gets a 0. Here we demonstrate with lights to show the 1s and 0s. After seeing how an inverter chip worked, we wanted to see what would happen if we pulled out the input wire to see if the light would turn off, but it did not. In fact, the reason it didn't was because when you pull the wire out, it actually floats to 1 instead of floating to 0. So you can't make any assumptions about where the voltage will be when you disconnect a wire. In our next step, we replace the lights with an oscilloscope and the 5-volt power source with a function generator on the square wave. Here we see what we saw.
Next we used a triangle wave to see and measure what the transition between high and low was. As you can see, we measured it to be 4.5 microseconds.
The next 3 pictures show us exploring the hysteresis of the chip. If we push the chip fast enough, the graph breaks down.
Lastly, we connected all of the gates together to measure the delay of a single gate. We ended up finding out that the delay was about 0.01 microseconds.